Hey everybody, welcome to our 14.1/2 lesson. Your book combines or adds tangent into 14.1 and 14.2. So I decided to combine this into one lesson where we just learn how to graph tangent. So in this case, there's a handout that you need to print out. So if you haven't printed out the handout, please do so before you continue the video, and then resume as soon as you're ready. All right, so on your video, or on your handout, I apologize, you're going to notice that the first thing we're going to do is discover the graph of tangent. And remember that tangent is, we have an identity that says that tangent is just sine over cosine. So in this case, in the table, I gave you, for every degree and radian value that is important on the unit circle, I gave you the sine of theta as well as the cosine of theta. And you can use the identity sine over cosine to get the tangent of theta. So I'd like you to fill out the table and then also plot all the points on your graph as carefully as you can. One thing to note, everywhere where there's an undefined value that results from division by 0, that'll be a vertical asymptote. So take a few minutes to see if you can fill out this table and then plot the points on the graph as well. And then resume the video when you're ready. All right, so I assume that you've already plotted all the points and filled out the table. So I'm not going to fill out the table, but I will plot some of the points at least, just so I can make our graph show up here. So if I go through here and just plot a few of these. Let's see, we'll put in another one. And then obviously you'll have a lot more points than I do, but you should have at least the points that I'm putting on here. So now if we go to draw in our function here, we can see that we're going to, and we always approach the asymptote, right? So we're going to curve up and then start low and come through the function. It sort of looks like a sideways logistic growth function a little bit. And obviously, in all of these cases, this would go on forever. But this just gives you a sense of what this looks like. So what you'll notice here is that the tangent is interesting because we actually start our repeat from 0 to 180 degrees. The cycle begins to repeat again. This area right here that I'm putting a box around, this is one period of the tangent function. It looks a little strange because it's broken up with the vertical asymptote in the middle, but that's one period. You've also got another period from 90 degrees to 270 degrees, which looks a little more complete. But when we're graphing, we typically want to avoid horizontal shifts if we can. So we tend to graph based on the period that I put in the box there. But the thing to notice here is that the period is different than sine and cosine. The period is 180 degrees, or just pi, which means when we're finding our b value, we use 180 degrees or pi instead of 360 degrees or 2 pi. Also, our amplitude is 1, but in this case, our amplitude is a little bit different. Our amplitude actually impacts the 2 points that I'm circling up here. In other words, the 2 points at sort of the 45 degree and 135 degree mark. So if our amplitude is 1, I'm just going to say that affects the 45 degree or pi over 4 point. So it affects how quickly our tangent function rises and falls. So it's a slightly different definition of amplitude in this case because of the shape of the tangent function. So let's go through an example of this together with a lot of modifiers as well. So you can kind of see the whole thing in one flow. So in this case, 2 tangent 1/2 x minus pi over 2 all plus 1. Now notice this one's already factored. If it wasn't factored, you would need to factor it first. so that the x or theta is alone. So in this case, our amplitude is 2. Our vertical shift is 1, in this case, up 1. Our phase or horizontal shift is to the right, pi over 2. And our period is pi over 1/2. So our period in this case is going to be 2 pi, because it would have been pi and then we're doubling it. So if we go to plot this on our graph, the first thing that I'm going to do here is put in my midline. So my midline is going to be at 1. My amplitude is 2 in either direction. I'm not going to actually plot those lines in like we did for sine and cosine because they don't have quite the same meaning, but we'll make a note of that as we're doing our 5 key points. We know that we're going to start at 90 degrees. And if it wasn't already labeled on here, you would be labeling these. But we'll start at 90 degrees and we'll extend a little bit beyond 360 degrees because we need to go all the way to 450 degrees because our period is 360 and we're starting at 90. So in this case for tangent, if we think about our 5, or I guess perhaps the easiest way to think about this is starting by actually putting in our vertical asymptote in the middle. So I'm going to place my vertical asymptote at 270 degrees because that's in the middle of our cycle. And then we know, so we're going to start at 90 degrees. And remember that we're vertically shifted up 1. And then our period, or our amplitude is 2, which means our 180 degree point has to occur 2 points up from our 90 degree point. And then we can draw in this curve. And similarly, on the other side, our 360 has to happen 2 points down from our midline. And our 450 degree point will happen right at our midline. So this would give us the other cycle of our curve. And again, we want to include arrows to show that we're going onwards forever in both directions. So this would be one cycle of tangent. Now, if you wanted, you could have done this slightly differently. I'll add in sort of a continuation here, because you could think about this as going in a slightly different direction instead, just depending on, kind of how you wanted to think about it. Because you could think about it as, well, there has to be another vertical asymptote here, negative 90, and then you could continue your cycle with a point at 0 and going downward like that. Now notice the green part would only make sense if you wanted to do a period that went from negative 90 to 270, which is not exactly what our equation described, which is why, so the black would be, what I would do is what I would consider to be one cycle. But if you include the green and the black and combine them between the two vertical asymptotes, that's another cycle, just to demonstrate that. So you can kind of see what that looks like. So I want you to try one of these on your own as well. And notice that this one is reflected. So you have to be a little bit careful about that. But if you would like to, try this one and then take a look at, or resume the video, and you can see how I would approach this problem. All right, so if I started to look at this problem, the first thing I would notice is that we have a vertical shift up 2 because of our 2 value. Now at this point, this problem I put the 2 at the beginning rather than the end just so you would see it both ways. We have a amplitude of 1, but note that it's reflected. We have a phase shift, so a horizontal shift, or C value, that goes to the left, pi over 4, because it's plus pi over 4. And then our period is pi over 1, which is just pi in this case, because our b value is 1. So when we go to graph this, the first thing that we're going to do is put in our midline. So in this case, I'll put in my midline at 2. And then the next thing I'm going to do here is I'm going to go and start to plot my 5 key points. And our 5 key points here, our first one is going to be left at pi over, or I apologize, negative pi over 4. And then from there, we're going to go to 0 because, well, I guess I should go all the way out first. We have our last point would be at 3 pi over 4 because our total period is at pi, or 180 degrees. And then halfway in between those, we're going to draw in our vertical asymptote. And halfway in between the two would be at positive pi over 4. And then we also have points at 0, as well as 2 pi over 4 or pi over 2. So now if we go to actually plot in our points, we're going to start at our midline. But this time, rather than going up, because we're reflected, we're going down. So our point at 0 is going to occur at 1 because it's down 1 from the midline. And then we'll draw in our graph. And then on the other side, we need to end up in the same place. So we need to end up at our midline at the end at 3 pi over 4. But this time we're going to be up 1. And then we'll draw in our function as well. So you can see here that in this case, this is a reflected tangent function. So at the beginning, it's going down rather than up like it would for a normal tangent function. So that brings us to the end of our video. The two things I want to make sure that I emphasize here with tangent are that the period is pi rather than 2 pi. And also that, just like we did with sine and cosine, it's important that you remember to factor, if you need to, before you begin to try to identify the period or the horizontal shift. So give the homework a try and let me know if you have questions.